First things on the warm-up when you're finding the inverse, just flip the x and y values. So the y values before were 1/8, 1/4, 1/2. Those become the x values down here. And then the x values before, -3, -2, those become the y values down here. All right, so that's the first step. The other thing I want you to notice, I wrote down some asymptotes here. So one of them has a horizontal asymptote in green, y equals 0. That goes to the black line, so that's why I wrote that one up above the original function. That's the asymptote in green. And then the second one, the asymptote in red, goes to the blue line. And that one has a vertical asymptote instead, the inverse. So one of the nice things about asymptotes that I just want to make a quick note of is asymptotes, they switch x and y values just like everything else in an inverse. So they swap just like all other x, y values. When finding an inverse. Okay. So that's kind of important to note too, that whenever we find an inverse of something with an asymptote, its inverse will also switch. And then the last parts, it says write the equation for that would go through the point from the table for f of x. So one thing that I would use from last class when we talked about graphing these exponential functions, first the black line looks like an exponential function, and I labeled it f of x so that way we could see it. I remember there was the point 0, 1, like if you plugged in 0 for x, you would get 0, 1, and that point exists on here. And then the next one was the point 1, b. So in this case, it's 1, 2. So that means the b equals 2. So the way you could write this equation, f of x equals 2 to the x power. Kind of a weird way to think about it. We haven't gotten practice writing these equations, but that's the idea for just like a quick way to do this type of problem. Think about those exponential equations. And then the last part, number 4, says go ahead and write an equation for the inverse of this, f inverse of x. So when I do that, I can say y equals 2 to the x, and then I swap to find the inverse, x equals 2 to the y power. And then if I can't square root both sides because it's not a square root, I have to take the y root of both sides. So it'd be like y root of x equals 2. But then that's not going to get y by itself. I want to get y by itself. So this is where we talked about at the end of mod 1. We don't really have a good way of finding the inverse for this yet. And that's what we're going to start talking about today in class, specifically finding the inverse of this type of equation. Logarithmic functions help us find the inverse of an exponential function. That's the specific reason we have them. All right. So what we can do first is we can start by saying, okay, the definition of a logarithm, like we know, for example, like 2 squared equals 4, 2 to the third equals 8, that's 2 times 2 times 2. However, if we had something that's in the middle, like 2 to the x equals 6, all right, we know that x is going to be a number between 2 and 3. Okay, so mathematicians define the x value using a logarithm, and the way they would write it down is you solve for the x value. You write it as log base 2 of 6 equals x. So in general, what this is going to look like, this is kind of weird, but we would say we'd say if general would be log base b of x, or of y, sorry, equals x, if and only if b to the x equals y. So those are interchangeable. We can change forms that way. So this is the way we're going to change from one form to another. So just as subtraction is the inverse operation of addition, division is the inverse operation of multiplication, taking a logarithm is the inverse operation of an exponential equation. All right, that's the idea here. So this is going to be a little tricky because this is like the first new thing we've learned in math in a long time, right? We've done quadratics before, we've done exponentials before, we've done linear functions before, but logarithms are something that we've never really seen before until now. So we just got to be careful, pay attention, and ask lots of questions. I don't expect you guys to be experts with logarithms right off the bat, but we'll go ahead and talk about them and how we do these types of things. So easy ways to remember the form is you start with the base of the exponent. The base is the letter b, so b for base. And that's also going to become the base of the logarithm when we're changing forms. So base of the exponent becomes the base of the logarithm. All right, base of the exponent becomes the base of the logarithm. You might say the base moves to the basement. That's another way you could say it. All right. Something else that happens is logarithms solve specifically for exponents. So now as x goes to the other side, I'll say this a lot this unit. Logarithms solve for exponents. Okay, that's the most important part of the whole thing. All right, you're always solving for exponents. That's what the purpose of a logarithm is. And then we have the y, just kind of like what's left over? The y value. And that's what goes next to the logarithm. Okay, so you're going to do log base b, whatever the base is, base of the exponent becomes the base of the logarithm. And then the exponent itself moves to the other side of the equation. That's what you're solving for. Okay, that's the idea with a logarithmic form to exponential form.
So I've got a question.
Sure.
So when you're doing this sort of problem, right?
Mm-hmm.
Would you so if bx were 2 squared, right? Would you do 2 squared and then put that, for log b, would you put the result of 2 squared in log b, or would you put just 2 in log b, and then the x is also 2?
So what happens is we would not do the result. We would just break it apart, and we're gonna look at that right now actually. So that's what we're looking at right down here. So with the first example, for example, I have logarithmic form and exponential form. So we can see, hey, if it's log base 2, then that 2 becomes the base in exponential form. And then the exponent was 3, so that becomes the exponent in exponential form. And then what's left over? The 8.
So with all of these, it's sort of, rather than solving it, it's breaking it apart.
Right now, we're just specifically looking at how do I rewrite this from one form to another. But ultimately, when we get to the meat of it, we're always going to have an exponent or a variable for the exponent. And that's when we're going to use the logarithms to solve for that variable. Okay? But right now, we're just looking at basically what's it look like in general to switch from one form to another.
Okay, thank you.
Yep. So now the second example, we have base 4. So that should be the base of the exponent. And then to the 0 power, and that should equal 1. And that makes sense too. Like logically, if you think about it, 4 to the 0 power, anything to the 0 power equals 1. So it's always good to think about, does this actually make sense? Okay. So the next example, we're going to go backwards. We're going to write it from exponential form to logarithmic form. So over here we have the base 4. Now we have a base 12. So we're going to write this as log base 12. And then the exponent is 1, so it'll be equals 1. And then there's a 12 left over. That's where the other 12 goes, and then the exponent, 1 and 1.
So, sorry, close out something. I've got another question.
Sure.
What is the relationship between like log 12, 12, like that? Let's use that as the example. Is that like log 12, and then you can, like, that's how many 12s you have? Or is that like, is that another variable, or is that like...
So it's kind of a weird relationship, right? So the way it's going to be read out loud, I guess I skipped over that part, is up here. This will be read out loud as log base 12 of 12. That's how we'd say it out loud. Okay? And the base of the logarithm is, it's kind of telling us like, we're trying to figure out how many exponents we're going to need to get to the big number from that base of 12. So like, so we're saying basically it's like, hey, we have a base 12 and we're trying to get to 12. So how many exponents do we need? We need 1 exponent. That's kind of the idea with logarithms. It's kind of a weird way to explain it. But one thing you might notice with log base 12 of 12 specifically, it equals 1. And this actually creates a general case for us. Anytime we have log base b of b, it's always going to equal 1. So when these two numbers match up, they'll always equal 1, which is kind of a cool thing. All right. Let's take a look at another example here. We're going to go from logarithmic form to exponential form. The base was 1/4. So we'll say 1/4. And then the exponent is -1. And that equals 4. And this is another one where once it's in exponential form, it should make sense to us. Because what happens when you have a negative exponent? What do you do with the fraction? You flip it over. So 1/4 to the -1 power is the same thing as 4 to the first power. And 4 to the first power is 4. So logically, that does make sense. Okay. And now we'll take a look at one with some variables and an exponent in it. So this one, for example, says the base is 2. So we're going to put a 2 over here on this side. And then the exponent is x. And then the other side should be x squared. We'll just take the whole thing over. So the x squared goes to the other side. The exponent of x goes there. Logarithms always solve for exponents. So that's how we know where the exponent goes. And that's going to be true over here as well. This is a good example of, this is how we solve for an exponent. And the way we're going to solve logarithms is we're just going to put them into our calculator. So this is log base 15 of 225 equals x. That's what this last example would look like here. So if you guys have calculators, you should be able to put them into your calculators. The problem with calculators is some newer calculators will let you put any base you want into it. Older calculators might only let you put in base 10. So we'll talk about how to combat that in the next couple class periods. But for right now, all I want to do first is we're going to get in shape practicing changing things from exponential form to logarithmic form and vice versa. I have 8 problems here. I want you guys to try switching from one form to the other on these 8 problems. So take a few minutes to work on that now. Let me know if you have any other questions. I'm more than happy to answer those. I know it's our first time seeing this, so I'm sure there will be a lot of questions. Just type them into the chat. I'll try and answer the best I can. Okay, I've got those 8 answers posted up here for you guys now. I kept them color coded just like we did on the problems above, so hopefully that helps you out a little bit there. But the base of the exponent becomes the base of the logarithm and vice versa. And then the logarithms always solve for exponents. That's how I always remember these things, where the exponents go and where the bases go. And then the red number just kind of falls into place. It's the only place for it left to go. Okay. And for the exponential equations, problems 1 through 4, those are ones that are super easy to check on your calculator. Like 3 to the 4th power, that is 81. 7 to the 1st power is 7. As long as those make sense when you're realigning the numbers. Because if for some reason you got like 4 to the 3rd equals 81, well, that doesn't make sense, right? That doesn't work out mathematically, because 4 to the 3rd power is actually 64. So just as long as you can make sense of where the numbers go in which places, that's really important. All right, but that's kind of how you work through these types of problems here. Some examples about evaluating logarithms, like if I gave you one that was like log base 4 of 64, we can kind of guess and check on it. And what I mean by that is, so you can start by rewriting it as like 4 to the question mark equals 64. And then you can kind of think, well, 4 to what power gives 64? So like I could say, well, 4 to the 1st equals 4. 4 squared equals 16. 4 to the 3rd equals 64. So there we go. It's going to be 3. That's a good way to like guess and check. All right, is just try plugging in numbers until you find one that works. Likewise, maybe you have one that's like log of 5 equals 0.2. So that can be rewritten as 5 to the question mark equals 0.2. Another way to maybe think about it that might be easier than 0.2 is turn 0.2 into a fraction. Because if you do that, it's 5 to the question mark equals 1/5. And then you just have to ask yourself, okay, what type of exponent turns an integer value into a fraction? And that would be a negative exponent, right? If we were to make this a negative value, 5 to the negative 1, that would just flip it over and make it 1/5 to the 1st power. And that's what we need to do for that problem. And then the last one, this one's kind of a tricky one here. Log base 36 of 6, we rewrite that as 36 to the question mark equals 6. And this time, like, what's the relationship between 36 and 6? Like, there's some mathematical relationship in between those two numbers. How do you get from 36 to 6? All right, let's check there. Yeah, 6 squared is 36, exactly. Or you could say the square root of 36 is 6. Well, another way you can write the square root of 36 is 6 to the 1/2 power. So that means the exponent would be 1/2. Just remember that we can always rewrite a radical as an exponent as well. You could also say, oh, if I had to do the cube root of 36, that's 36 to the 1/3 power. Oops, sorry. So it's 36 to the 1/2 power, not 6 to the 1/2 power, sorry. The 4th root of 36 would be 36 to the 1/4 power. The 5th root of 36 is 36 to the 1/5 power. So that always works. So that's how we would get 1/2 for this last problem here. You'd say square root of 36 is 36 to the 1/2 power. So that's another type of exponent you could deal with. So the 3 types of exponents, you could have positive integer values, negative integer values, and then you could also have fraction values. Okay. I want you guys to try guess and check on these 4 problems here, problems 9 through 12. So give that a shot. All right, so the next part that I have here that I want you guys to try out, there's a lot of number lines here. We might not have enough time to get through all of them today, but we'll see what we can do. The whole idea is I want you guys to, we'll do the number 13 together. It says place the following expressions on the number line. Use the space below each number line to explain how you knew where to place each expression. So the first example is like log base 3 of 3. So I could rewrite that as like 3 to the question mark equals 3. Well, in this case, that's going to be a 1. So that means example A would fall right at 1. All right. Example B, log base 3 of 9. So I'd say 3 to the question mark equals 9. Well, in that case, it'd be a 2. So B would be 2. All right. And that's how we kind of figure out what these expressions are. And the negative, these represent negative exponents. And that comes in handy for like part C here because you're getting 3 to the question mark equals 1/3. So that means that would be C. And then 3 to the question mark equals 1/9. That's E, negative 2. And then this last one was 3 to the question mark equals 1. And that one would actually be 0. Anything to the 0 power equals 1. Okay, so that's like kind of how I want you guys to work through these number lines and try and figure out where values go. I do want you to be aware that it is possible to have numbers that will fall between number lines. It's possible to have repeats as well. So for example, you might have one that's like, let's say log base 3 of 6. And if I did 3 to the question mark equals 6, then that would be, we know 3 to the first equals 3, 3 to the second equals 9. So that means like point F, which I just made up, is going to fall somewhere between 1 and 2, probably a little bit closer to 1 than 2. So that's kind of where I'm putting it. But I'm just going to put it somewhere between 1 and 2 here. So that's how I put point F on this graph. So there will be points when you're going through these values that might fall between 2 numbers. And you could have repeat points. So you might have 2 answers for the number 1. So you can put A and D both listed at number 1, for example. All right, so what I want you guys to do now, work through examples 14, 15, was it all the way to 20. Try and get through as many as you can, rewriting these and doing the guess and check method. See how you're doing with these types of problems. This is something I would normally have you guys do together in class, but unfortunately we're not in class. So give those a try, rewriting them, guess and check. Let me know what you're finding out about these values. So the common logarithm is log base 10 of x equals log of x. And then the natural logarithm is log base e of x, or we can write it as natural log of x. So you're just going to see ln. So when you see a logarithm that doesn't have a base written, it's always assumed to be log base 10. And when you see a logarithm that has ln instead, then that's always assumed to be log base e. That's all that means with special logarithms, okay? The common logarithm and the natural logarithm. All right, so again, the way your calculator thinks about this, if I give you an example, like let's say log of 6 equals x, and we're trying to figure out what's the exponent, your calculator just thinks, okay, well I have to do 6, exactly like how we guess and check. It thinks about, oh, okay, 6 to what power equals 10? And then it's going to spit out that number for us. So like 6 to the first power is 6, 6 to the second power is 36. So it's going to be a number like 1.2 or 1.1, right? That's how your calculator would calculate x. Just kind of thinks about it like we do, but it just does it much faster and much better than we do. The last 4 examples here just says round each one to the nearest hundredth. Just practice putting them into your calculator. So whatever calculator you have, if you're using a phone, I think you can do logarithms, common logarithms, natural logarithms on your phone just by turning it sideways. All right, so that's a possibility as well. But so the first one is log of 12, so that's assumed to be log base 10. So you just put it in your calculator, round to the nearest hundredth, that's 2 decimal places. And it would come out to like 1.08. All right, and then I want you guys to try the other 3 problems. So just plug them into your calculator real quick, try it out. Make sure you're using your phone, or if you have a calculator, use the calculator so you know how to enter these into the calculator properly. And then we'll check our answers in just a second here. I want to talk specifically about parts B and D though, because part D, we talked about this a little earlier, log base E of E. So anytime you get the bases to match up, the base and the number next to it to match up, it's always going to equal 1. The other one that happens here is log base 10 of 1. If we rewrote that in the other form, it'd be 10 to the question mark equals 1, and the only number it could be is the 0 power. So anytime you see log base something of 1, log base b of 1, that's always going to equal 0. All right, log base b of 1, any base of 1 is always going to equal 0. So that's something else that I want you guys to try and remember for these logarithms. And we should have seen that happening on our number lines as we were working through as well. I know we went through it kind of fast there, but that's the idea there. For your assignment, problems 1 through 4, just rewrite the equation in exponential form. Problems 5 through 10, evaluate without using a calculator, so use that guess and check method just to practice. And then problems 11 through 13, just practice plugging it into a calculator. And then the last one's problems 14 through 17 are kind of like challenge problems, just trying to, again, think about it a little bit more logically. Those ones are a little tougher because you're not going to get nice integer values. So you have to think about how can I get to those numbers. So it might need to be a fraction, might need to be a negative, those types of things to think about for the last 4 problems. Okay, so they're all going to, I think they're all going to be fraction answers. So just think about how you can get there using a fraction. That's the tricky part for those last 4 problems. All right, but please let me know if you have any questions at all. Office hours, this is going to be a new topic for us, so just practice. It's not going to go away anytime soon.